For the first few decades of the 20th century, naval supremacy came down to a straightforward equation. The nation with the heaviest battleships and the largest guns ruled the waves. But this massive artillery had a strict geographic limit. A ship could only project power as far as its guns could throw a projectile, which meant a navy's reach stopped right at the physical horizon. This historical archive shows one of the earliest attempts to break that horizon barrier. Navies began looting seaplanes onto the back of modified cruisers to fly out and scout ahead of the fleet. It was a clunky process. Because these early planes used floats instead of wheels, they had to be physically lowered into the water by cranes before they could take off. In active combat, that slow setup made them sitting ducks. To truly fight over the horizon, engineers realized they needed to solve a nearly impossible architectural puzzle. They had to figure out how to take an entire high-speed runway and bolt it to the pitching, rolling surface of the ocean. By the height of the Pacific War in 1942, that puzzle was solved. The aircraft carrier successfully dethroned the battleship as the primary weapon of the sea. Yet this new vessel was a walking paradox. It could deliver a staggering amount of offensive force, but to do so, it had to carry thousands of tons of highly combustible aviation fuel and high explosives inside its hull, making it incredibly fragile. To understand how these floating runways dictate global geopolitics to this day, we need to peel back the steel and look at the three distinct layers of their internal anatomy. This diagram of the USS Enterprise shows a cross-section of a World War II carrier. Starting at the lowest level, deep beneath the waterline, you'll find the ship's greatest vulnerabilities: massive tanks holding aviation fuel and heavy munitions. Storing all that destructive potential in one enclosed space posed an existential danger. We can look at the Japanese carrier Kaga during the Battle of Midway to see exactly what happens when those defenses fail. A single 227-kilogram bomb dropped from an American plane pierced the upper decks and detonated right inside a fully fueled compartment. That blast triggered an uncontrollable chain reaction that doomed the ship. The brutal reality of carrier design is that the very resources needed to launch an attack also turned the ship into a floating powder keg. Moving up one level, we arrive at the hangar deck. This is a massive internal cavern directly below the roof, where planes were stored, serviced, and armed away from the weather. To move multi-ton aircraft between this internal garage and the flight deck above, carriers relied on specialized heavy-duty elevators cut directly into the structure. How navies protected this space varied wildly. The British Royal Navy, expecting to fight in the confined waters of the Mediterranean, built thick steel armor over their flight decks to shield the hangar below from falling bombs. The American and Japanese fleets took the opposite approach. They stripped away the heavy deck armor to reduce weight, which allowed them to build larger hangars and pack their ships with dozens more aircraft. A navy's entire strategy, whether they prioritized defensive survivability or an overwhelming initial strike, was baked right into the physical blueprints of the ship. Finally, we reach the roof, the flight deck. It looks like a parking lot, but out on the water, maneuvering dozens of planes loaded with explosives on a cramped pitching runway is terrifyingly dangerous. This diagram outlines the chaotic math of getting planes airborne. Crews faced a relentless bottleneck, the 10-second clock. To synchronize a squadron, they had to cycle a fighter into position, run checks, and launch it every 10 seconds. Because the runway was so short, the ship had to turn and steam at top speed directly into the wind. This generated wind over deck, forcing fast-moving air over the wings to give the planes enough artificial lift to avoid falling into the sea. Landing is an even tighter margin of error. Returning pilots had to snag a specific arresting wire on the deck every 20 seconds. Miss the wire, and you crash directly into the planes parked at the other end. Winning a battle at sea wasn't about artillery range anymore. It came down to a crew's ability to safely manage this high-speed mathematical chaos on the roof of a moving ship. Once this system was perfected, naval warfare was completely rewritten. Two opposing fleets could now seek out and destroy each other across hundreds of miles of ocean without ever making visual contact. The definitive proof came in June 1942 at the Battle of Midway. Carrier-based dive bombers devastated the Japanese fleet. proving that the era of the massive battleship was officially dead. However, these World War II carriers still had a major architectural flaw. Because the flight deck was a single, straight line, a ship couldn't launch planes off the front and land them on the back at the same time. The traffic jams were simply too dangerous. That geometric bottleneck put a hard ceiling on how fast a carrier could operate, a problem that became critical as planes got heavier and faster. This diagram highlights the 1950s British innovation that solved this problem, the angled flight deck. By shifting the landing strip off-center, the geometry completely changes. A carrier can simultaneously catapult aircraft off the bow while recovering planes on the angled runway. Crucially, if a fast-moving jet misses the arresting wire on landing, the pilot can just hit the throttle and fly safely out over the water, rather than plowing into the planes parked at the front. That final evolution turned a vulnerable floating experiment into the ultimate instrument of modern military reach. The engineering proves a simple truth. The nation that can project an airbase onto the ocean controls the world below.